Hello and welcome to today's webinar. My name is Tyler Reid. I'm the Manufacturing Applications Manager here at GoEngineer, and today's CAMWorks webinar is covering the Virtual Machine Simulator. This is a module that released with CAMWorks a few years ago, and it has had quite a bit of popularity within our customer base, especially for users who are using expensive machines, expensive tooling, expensive stocks, and who are really concerned about avoiding any unnecessary repair costs or maintenance costs, or are really concerned about delays in machining their parts correctly the first time. The Virtual Machine Simulator for CAMWorks is a true Gcode machine simulator. This means that it simulates reading from the exact same Gcode file that CNC programmers and operators are loading into their machine tools. This is in stark contrast to a typical simulation in a CAM program where the simulation is happening before the program even exists, before the Gcode file is created. The Virtual Machine Simulator is a full machine simulation with collision detection. You will see here in the demo that we are not just simulating the part and the fixturing and the tables. We're also simulating the entire machine spindle. We're machining any sort of miscellaneous air blast tools or probing tools or anything that you might have within the machine is there and present and is constantly being checked for collision detection. Along with collision detection, we're also simulating the removal of the material. We are constantly looking and checking if our machine tool is moving out of the limits of the machine. We do have the ability to virtually jog the machine so that we don't actually have to go up to the actual machine, jog it to verify that we are where we think we are. We're going to get the most precise time calculations. CAMWorks does a good job of estimating time, but it is not as precise as it could be because there are certain components that CAMWorks cannot account for. It really doesn't account for the acceleration and deceleration of your axes, or the speed up or slow down of your spindle, or the tool change from tool 2 to tool 18. Most people don't go through the effort of implementing that into CAMWorks. Along with being a machine simulator, we do have some program editing capabilities. We do have the ability to compare the model as we've cut it against the SOLIDWORKS CAD model and just verify if we've missed any areas and how accurately we have cut the model using the Gcode that we've generated. We also have the ability to measure, and lastly, we can verify not only the Gcode but any sort of probing routines or macros that you might have in your Gcode file. The CAMWorks Virtual Machine Simulator is integrated into the SOLIDWORKS and CAMWorks environment. It really is the only tool of its kind that is launched from the CAD tool and the CAM tool and automatically loads things like the tools, the tool holders, the tool blocks, the stock shapes, any sort of fixturing, and also the finished part model so that we can run a comparison. All of those are loaded up for us. So to go a little bit more in depth on how the Virtual Machine Simulator differs from just a standard system simulation. As I mentioned before, the system simulation runs inside the CAM tool, and it's really a programming tool. It's there to help the programmer verify that all of the features are being cut, not necessarily how accurately they're being cut. It also is there to help the programmer just make sure that they've got the base program down. It's not a verification tool. There are things that it can't detect. Unforeseen programming errors, incorrect feeds and speeds or depths of cut. These are things that simulation within a standard CAM system don't look for. Faulty post-processing. Anything that's going to happen in the code is completely invisible to the system simulation. Things like CAM cycles and subprograms incorrectly being generated. And then lastly, since we're in the full machine environment, unexpected or hard to anticipate collisions between the tools or fixtures and other machine components. Why does that matter? It should be fairly obvious. If we are missing all of these different areas of verification in the system simulation, then we really aren't 100% confident in our programs before we actually take them to the machine and run them. Avoiding just one or two machine collisions can pay for this module, especially when you were talking about the potential cost of repairs and maintenance and the downtime that is associated with hard crashes. Even if we take out the collisions, we're going to reduce the programming time and the setup time and the machining time by having more of information available to the programmer to allow them to make better decisions. And we've all broken tools, we've all touched our fixtures, but if we can avoid those by verifying the actual Gcode before we ever get up and move over to the machine, then that's going to reduce our scrap costs, reduce our tooling costs, and reduce our fixture costs. Last slide before we jump into the actual software. I did want to talk about the different modules that the Virtual Machine Simulator is available in. It's the kind of the typical standard professional premium packages. The standard package is launched from CAMWorks, and it simulates the Toolpath CL data. It is not the Gcode, and so it's very similar to the system simulation, except it's expanded beyond the scope of just the part and the fixtures. It does run inside the machine environment. The professional package is going to be our most popular package on this module. It delivers the best bargain, and it also delivers the base functionality that most people are after, and that's the Gcode simulation. So it is launched from CAMWorks. It simulates the full Gcode in the full machine environment. It automatically loads up the tools and the fixtures and the stocks and all of that. The premium package is really for customers who are looking to simulate Gcode files, not only from CAMWorks, but maybe from some other CAM tools. So the premium package can be launched from within SOLIDWORKS, or it can be launched as a standalone application. It simulates the Gcode files just like the professional package does. And then on top of acting as a standalone application, it also gives the user full ability to create their own machine models. Typically for our professional customers, we at GoEngineer coordinate and work with the customer to build the machine models that are necessary to make use of this machine simulator. For those of you who are interested in doing it on your own, say you have many machines and it's going to be a pretty large undertaking to get it done, then the premium package might be worth your time because it's going to give you the ability to create, assemble, and modify machines. So we're going to jump into the software and take a look at a few different examples so you guys can get a feel for what it really looks like to use this machine simulator. I have 3 different examples I'm going to go through. We'll be able to step through the majority of the functionality of the machine simulator within just one example, but I wanted to give you guys a taste for the variety of types of machines and types of functions that we can output from CAMWorks into the machine simulator. As you guys might be aware, CAMWorks is a full-fledged CAM tool. When it comes to milling, we can do 5-axis simultaneous milling. Whether it's table, head, we can do all of it. When it comes to turning, we can do front and rear turrets, 4-axis turrets. And mill turn, taking a lathe or taking a turning machine and putting milling tools on it, the live tooling, and simulating that, using the spindle as a servo motor, locking it into place with the C-axis, having a live tailstock, transferring parts from a main spindle to a sub-spindle. CAMWorks can program all of that, and the machine simulator can simulate all of that and actually more. So I'm not going to go into the details of programming these parts because we have other YouTube videos available to step through the process of that. I've pre-programmed these, and we're going to go through what it looks like to launch Virtual Machine Simulator and use it. So in this particular case, we have a turned part. And in the system simulation, we can watch this part being cut. So we're going to get some material removal. We are doing some basic collision checking. At some point, this is going to transfer to the subspindle. We won't really get a full simulation of that. It just kind of jumps over. At the end of this, we can run a comparison, and I can see that there is a little internal groove there that I haven't programmed. We're undercut in that area. Now, if I'm happy with this program, I would typically go to post-process this. And I'm creating my Gcode file for the machine that I plan on running this on. Now, if I want to go one step further and run the machine simulator, I'm going to just simply check this box and generate the Gcode. Now, when I accept that Gcode, it's actually going to launch the machine simulator. The machine simulator is going to automatically populate my tool turret with my tools and their holders. It's going to automatically load up my stock material. We have both chucks being read in from the CAMWorks environment. And we also have the Gcode. Over here on the left is going to be our Gcode file that was generated. So from here, I'm going to start a simulation. Now, when I start a simulation, I can simulate line by line. I can tell it to move as fast as it can while continuously updating the stock. I can tell it to move as fast as it can while only periodically updating the stock. I can turn collision checking on. I can turn it off. I can tell it to check but just push through it and notify me when it collides. I can start from the beginning of the Gcode, and I can start on any line I want to. So I'll kind of walk you through what all of these look like. Before we start, notice that our entire machine is loaded up into this environment, even the outer sheet metal we have. Sometimes I don't want to see all of it, so I can very rapidly change my views. You can see this view is just showing me my tools that got loaded up from CAMWorks and my stock piece. Whatever view you use is kind of up to you and your preference. Another thing, speaking of views that we can turn on and off, are Toolpath Traces. So I'm going to go ahead and turn them on to start with, and I'm going to start simulating line by line. And it's reading down through the Gcode. So you can see over here on the left, as I click, I'm reading line by line, and I am getting a little green trace of my tool tip. If I want to speed it up, I can simply press play, and it's going to speed up. At some point here, we are going to get a transfer from the front spindle to the subspindle. So the subspindle will travel, it will wrap it over, it will clamp on the part and pull back. And then we see it machining on the back side. Once it's finished, I can run a comparison just like I do in the system simulation inside CAMWorks. Unlike CAMWorks, I can actually control the thresholds between my different colors, telling me how close I am to the finished part, if I'm overcut or undercut. I can add different steps here, and I can adjust the threshold on each step. So I'm going to go ahead and let it analyze, and we can see, just like in the original CAMWorks model, it is showing that I am undercut on that internal groove. Now, at any point, if I'm trying to verify my program, there might be spots where I find collisions, and those will usually be signaled down here in the simulation history area, the little timeline box at the bottom. If I find an area that it's warning me about, I can simply click on that If I double click on it, it will highlight the line over here in the Gcode. It will tell me what it's warning me about. In this case, it's saying materials being removed during a rapid movement. And I can actually come back over to the Gcode and start wherever I'd like to. So we'll show that in a different file here, but I kind of wanted to give you a general overlook of the user interface. Within this Gcode file, I can make adjustments to it. So I can overwrite, say, feed rates or XYZ coordinates. I can add comments, and I can save out a new Gcode file from this area. When it comes time to taking measurements of my cut file, I can do that as well. If I wanted to pick up, for example, a radius, I can click 3 points, and it's going to create a radius for me to measure. And I can get an actual measurement of my file as it's been cut using the Gcode that's going to be loaded to the machine. Some of the other controls up here, I can take snapshots of the simulation. I can video record the simulation. I can get some tool data. We'll show that on a subsequent example here. I can see status of the machine control at any point. So what that means is I can see the absolute position of the tool, the relative position of the tool. I can see what work coordinate offset I am in at any given time. I can see the feed rate, the tool number, the tool length. In this case, I can see G18 and G40 are active. So as it is reading through the simulation, it's actually updating me constantly. So we're going to go ahead and change to a second example here. So when I'm done in here, I simply exit the module. Now, if I spotted any sort of changes, I could come back into CAMWorks, make a change to my toolpath, repost, and relaunch the simulation. It's seamless. We're going to step up in complexity a little bit here. This is a common scenario for CAMWorks users, and that is assembly machining. Machining multiple parts all within one program. In this case, we have those parts locked in vices on 4 sides of a tombstone. The idea here being we're going to be programming this on a 4-axis horizontal mill. Again, if we run the simulation, within SOLIDWORKS, we can see the fixturing, but we're not getting all of the information, and we're not running a true Gcode simulation here. So really what we want to do is we want to post-process this. We're going to develop the Gcode file. We're going to run the simulation. Now what we'll see here is that the machine simulator will load up not only the parts, but all of the fixturing and all of our tools. Again, we have a very complex machine model. We have our Gcode. And we will start simulating again. Now, as you can imagine, this could take a while. It's doing a lot of calculations, and that's why some of these other speeds exist. If I pause this and I tell it to go as fast as possible while still updating the 3D view periodically, what you'll start to see along the bottom is that the simulation bar is making progress, but we're not seeing every single movement. I'm going to go ahead and turn the tool traces off as well. And we're getting some warnings here and there. These are warnings probably similar to what we saw prior, rapid moves moving through the part. You do have control over the accuracy and the precision of this simulation. So we do have some control over the time it would take to simulate some of these. And we're finished with our Gcode, and it actually doesn't look like all of it posts. So there might be some issues with our subprograms being generated. A little bit interesting there. As I mentioned, at any point, I can go to any line, any line of concern, and I can right-click and tell it to restart from that line and also update the stock shape. So it's going to start from the beginning, simulate the stock up to that line. It's going to put me on that line with the stock shape as is. And that's going to help me diagnose my Gcode and make any hand edits if needed, or signal to me that I should be going back into CAMWorks and making some changes to my Gcode. So when I right-clicked and told me to start on this line, I could zoom in, and I can then go line by line by line and diagnose any potential issues. We do have some info on our tool cribs as well in this scenario. So if I wanted to get more info on a particular tool, either the holder or the tool itself, I do have that available to me. I can make adjustments to the tool size or the tool height offset or the protrusion in this window. I can search within my Gcode. We do see an A180 move within this window here. If I wanted to search for other A moves, I can see that they're not present in the Gcode. We're going to go ahead and try a different post processor here. And let's see what a different post processor results in. So I'm going to go ahead and regenerate the code. Now I'm running this on the same machine, so I didn't change my machine. But if you had multiple machines and you wanted to simulate on a different machine, we absolutely could change machines as well. So you can see it's fairly simple to go back to CAMWorks, make a change, relaunch the machine simulator. Not sure if this is going to operate correctly because this post processor output B codes instead of A codes. And maybe that's what it needed. Now, one thing I don't like is that it's machining one part in its entirety before it indexes. So let's change that. We're going to come back to CAMWorks. We're going to sort these operations. And we're going to reduce the number of tool changes by telling it to index during tool changes. Now, that may mess with my clearance planes. So this is where Machine Simulator really helps. The nice thing here is that I'm going back and forth in the virtual world, and I can do it within seconds. What I'm not doing is generating a Gcode file, throwing it on a USB stick, walking over to my mill, loading the file, adjusting the Z offset so I'm running dry over the air, and watching it move in person. I'm not losing any accuracy, but I'm saving a lot of time. Yep, there's definitely some problems there. Our clearance planes are not pulling back far enough, just kind of like how I imagined here. You guys see that? Now I have it set up to cut through collisions. I can tell it to pause on collisions, and as soon as it collides, it's telling me. That was a pretty hard crash, so hopefully you would catch that, but if you didn't, you'd be buying a new vise and even potentially a new tombstone there. Let's jump over to the last example. This is going to be full 5-axis milling, pretty standard 5-axis part, some sort of impeller. We do have only the finished passes programmed on this, so the machine simulator is going to start warning that we're taking too deep of a cut, but we totally expect that. The system simulation, you can see the stock shape looks like it came off a lathe. It's turned to size, and we're just doing the finished passes between the impeller blades. So we'll go ahead and generate the Gcode for this and launch it in the machine simulator. For this particular one, I have a Trunnion style machine selected. So you can see this, the way this one is set up, that we have a pretty common machine tool setup. You guys can probably tell or guess the machine manufacturer based on that air blast hose shape. But this guy always seems to get in the way. So he's in our machine simulator, and it becomes especially a concern when we have a trunnion setup here. We're going to pull open the Gcode, and we are just going to let this run through. We do see some statistics over here on the right. We can see the machining time. We can see the exact second it is at every point. We can see the tool change time, the time it's going to take to speed up the spindle, turn the coolant on. At the end of this, we're going to have a very precise time to be able to do scheduling or quoting. So if you get paid by the hour, you might run this and this speed, but most people don't. So we're going to go ahead and let that start running a little bit quicker while just periodically updating that 3D space. Now it is doing the full calculations. It's doing all of the collision checking. It's just not visually updating it, and that's what allows it to run a little bit quicker. It does run a little bit choppy, and I'm sure watching live over GoToMeeting, it's going to be even choppier. But at this point, we really are not trying to watch it. We're just trying to get to the endpoint and have it confirm or deny that we are on the right track and crash free on our part. So that's about it. You know, I've essentially showed you most of what there is to see and do in the machine simulator. It really is a verification tool. So ideally, we're not having to do anything but let it run and let it tell us whether or not there's a collision. If there's not, then we just take that same Gcode file and take it to our machine and run it confidently that we're not going to have any sort of mishaps. Now, if there is a collision, great. We just avoided a potential costly mistake over at the machine, and we're probably going to save a lot of time fixing it here digitally rather than in person. So that's about it for today's webinar covering the CAMWorks Virtual Machine Simulator. To kind of just recap what we talked about, the CAMWorks Virtual Machine Simulator is an add-on to the CAMWorks package. It comes in both standard and professional packages, but also a premium package. Most users are going to be interested in the professional package because that's the first area where you get the Gcode simulator. And for those of you who are interested in running and simulating programs not generated in CAMWorks, then you might be more interested in the premium package. They all do collision checking with the tool, the shank, the holder, but also the machine components like the spindle, air blast, any sort of fixturing, the trunnion, anything that you can model up and see, it's going to be simulated. The goal here is to spend maybe a couple more minutes at the computer, but eventually moving to the machine quicker and being able to jump into actual machining and creating chips faster. So I want to thank you guys for joining on this overview. If you have any questions, you can shoot me an email at treid@goengineer.com. Be sure to check out our YouTube page, youtube.com/goengineer, for more webinars and more CAMWorks and SOLIDWORKS content than you probably have time to watch. Thanks again for joining. Have a great weekend, and I'll catch you guys later.